Good day and welcome to our class. Today we shall consider the concept of sphere in three-dimensional analytical geometry. First of all, let's define what a sphere is. So we have it here. We say that a sphere is the locus of a point which moves at a distance from a fixed point. So what that simply means is that it's a set of points that is moving in such a way that its distance from a fixed point here is always the same thing. No matter where it moves, it will always be the same thing. So this fixed point that they are talking about here, we call it the center of the sphere. While this equal distance here, we call it the radius of the sphere, and this is the circumference of the sphere. Now we'll quickly move to equation of a sphere. Now, the equation of a sphere is in three forms. So we need to consider the three cases by which you can find equation of a sphere. The first one, this. So we say that this is the first one. We say that if a sphere is having radius r and that sphere is also centered at origin, then this is the required equation of that sphere. So this is r square representing the radius. And if the sphere is having radius r and is centered at this point, let's say ABC, A comma B comma C, then this is the equation of such sphere. So it's just equivalent to that of equation of circle under two-dimensional analytical geometry. We are only including the z part. For the two-dimensional plane, we consider only x square plus y square is equal to r square. Also, equation of sphere, if the endpoint diameter is known, that is, if this is the sphere and this is the diameter of the sphere, if you can know this and we can know this point, let's say this point is point s1 comma y1 comma z1, and this is s2 to this. So let's say they are the endpoint diameter and they are known, the equation of such sphere is equal to this. So these are the three ways of finding equation of sphere. These are the three cases. Now we now move to the general form of a sphere. Generally, how sphere looks like. So the general form of a sphere. So let's recall from this place. From this, let us recall from this, and we have this. Now let us expand it now. By the time we expand it, we'll be having s squared. But let's expand everything. I will write it. I'll pause you and I'll write it out. Let's expand everything. So we are going to have this. By the time we expand this, this. So which is still equal to r squared. Now, if you want to write it, we take the square first. S squared plus y squared plus z squared. We take this one. So we rearrange it now and we get this. So I've expanded it and I've simplified. Now, all these things can be written in short form like this: s squared plus y squared plus z squared. I want to turn this place to plus. So this, we can now write it as 2fs. This one to 2fy plus this one this is, let me use another letter, 2g. This is 2hz plus, let's use the whole of this for k, which is equal to 0. So this is the general form of a sphere. The question now is, what is our f? F is minus a. What's our g? G is minus b, and our h is minus c. As we have seen from here, also our k is equal to a squared plus b squared plus c squared minus r squared, the whole of this. So from that place, we can get our center and the radius. So center here will just be, our center is a comma b comma c, as you have seen from here. So the center here will just be minus f comma minus g, comma, minus h. And if you make this r desired formula, the radius will just become a squared plus b squared plus c squared minus k. So that will be the, so we normally use this when we are finding the center and the radius of a sphere when a sphere is given, but a sphere will be expressed in this format. Let's write it out for a clear explanation. So for clarity's sake, we have written it out. This is the general form of a sphere. So where the center of the sphere will be written as this, and the radius, remember here we wrote a square, but a is same thing as f. A square is same thing as f square. So in this place now, we have now converted it to f squared plus g squared plus h squared minus k. So this is the general form of a sphere. And let us now take example. We have example here. Find the equation of a sphere centered at this point and has radius 3 units. So definitely we are making use of the second formula, and that is this. So there's r squared here. In this place now, our a is 2, our b is 2, and our c is minus 3. So we substitute it so that we have s minus a, s minus 2 squared plus y minus b. Our b is also 2 squared, z minus, but our c is minus 3. To make this place will be plus, is equal to r squared. Our r is 3. So this will be equal to 3 squared. So the next thing now is we expand it. By the time, let's expand. Expansion, I believe, sorry, this place will be 3. It's not c. Our c is. By the time we finish the expansion, we should be able to have this. This is for the expansion of this. This is for the expansion of this, and for the expansion of this. This is it here. And this is 3 squared, which is 9. So we can now simplify so that it looks like a sphere. Starting from this to y squared to z squared. We take the one for x, which is 4x. We take the one for y, is 4y. We take the one for z here, which is 6z. And the constant 4 plus 4, that is 8, is equal to 0. Observing that 9 minus 9 is gone. So this is the required equation of the sphere. Let's take another example. We have another question here. Find the equation of a sphere whose diameter extremes are 431 and 277. So if the diameter extremes are given, or the endpoint diameter, so the equation of sphere will be given as this. Now this is our s1 y1 z1 and s2 y1 z2. Now what we are going to have will be x minus s1. Our s1 is 4, s minus s2, our s2 is 2, y minus y1, our y1 is 3, y minus y2, these are y2 here, y2 is 7, that is easily seen, z minus z1, which is 1, and z minus z2, and z2 is also 7, equal to 0. So the next thing is we can easily expand this and this. So if you expand and simplify, we are going to get this. So this will be the final answer to the question. Now let us take another example. We have another example here. Find the radius, find the coordinates of the center and radius of this sphere. You can do it in two ways. The first way is we need to recall the general form of the sphere. That is this. Now, if you compare it, you see that this is minus 6 is the coefficient of s here. So therefore, we can now say that 2f is equal to minus 6. Also, there is coefficient of y here, which is 2g. You can see that 2g is the coefficient of y here, which is 8. 2h is the coefficient of s. Z, which is minus 10 here. And this is our k. K is equal to 1. From this list, you see that f is minus 3, g is 4, h is minus 5, k is 1. So from that place, we can find the center. So we know that the center is this. And if you put it there, f is minus 3 before. This place will be 3 minus 4. H is minus 5. Then minus h will be 5. So we know that our radius is this, which is same thing as we know our f. The f square will be 9 plus we know our g square will be 16. That is 4 squared. We know our h square will be what? That 25. Minus k, our k is 1. So from this place, we can now find the value of our r. By the time we simplify, this is 25 plus 25, 50 minus 1, that is 49. Square root of 49 is 7. So the radius is 7. Now, another way by which you can solve the question, we follow the use of completing the square method. That is, you start from this. So the next thing is you rearrange. Take all the s to s, bring y to y, and take the constant to the other side as follows. Now we have rearranged it like that. The next thing is we complete the square of this. Completing the square of this, I'll add square of half of the coefficient of x. I'll do the same thing for y. Coefficient of y is 8, so the square is, the half is 4 and the square is 4 squared. The same thing goes to z. Coefficient of z here is 10. So half of 10 is 5. You have 5 squared to the other side to hit. Now, whatever, in order not to be biased, whatever we have added to this left side, you must put it at the right side too. We have added 3 squared. We have added 4 squared. And we have added 5 squared. So that this one will just become s minus 3 squared. This one will become y plus 4 squared. And this one will become z minus 5 squared. So you observe that this is 49 and 49 is 7 squared. So we just need to compare it to the equation of circle. It's equation of sphere, which says, so if you now compare it, you see that a is 3, b is minus 4, c is 5, and our r is 7. So that the center becomes 3, minus 4, 5, and our radius is 7, which agrees with this. So when we are finding the center of a circle, it's even very easy. Center will be half of this, the negative of half of this, the negative of half of this, and the negative of half of this. So that will be the center. So let's consider another example. But before that example, let's consider this. Let's try this. We find the radius and the center of this sphere. Now let's take another example. We have another question here. Find the equation of a sphere passing through these 4 points. So since we have known the points that the sphere passes through, so we need to make use of the general form of a circle, and that is this. So we begin to substitute all these values one by one. Firstly, at that point, at this point, what we do is anywhere we see s, we put, since they have told us that the sphere passes through this point, definitely it must satisfy this equation. That is, this y, and z is 2 must satisfy this equation. So anywhere we see s and y is there, we put all these values there. So 4 square will give me 16 plus y is 1 square is 1 and z squared is 4. Now, this is 2fx, and our just be putting anywhere you see s, put it to be 4, y to be this, z to be this. So let's do that, and we are going to get this. So by the time we simplify, you are going to get this one. So we do the same thing for this at 0, 2, 3. So I'm going to pause the video now, and I'll substitute all these points in order to save the time, and that will give me the following. So we have all these equation 1, 2, 3, 4. The next thing now is just to find the value of these f, g, h, and k, and that is simultaneous equation involving 4 variables and 4 equations. So we do it anyhow we know it. But firstly, we can easily deal with some of this here by first subtracting these equations. So let's subtract 1 minus 2. So we subtract this minus this. So that will be 8f. By the time we subtract this minus this, that will be plus 2g. This minus this minus 2h equal to, this is minus 21 minus 4. That will give me minus 17. Let's call it equation 5. Let's keep that. Also, we can subtract these two. So let's say equation 3 minus equation 2. This minus, so that is 2f minus this. This is 0f. This minus this. This minus this. This minus this is gone. This minus this. So it will give us the following. Which is this. So finally, let's subtract as well. 4 minus 3. So if you subtract, some will go, and the remaining one will become. So we have these new 3 equations. So what we now have here is 3 equations with 3 unknown. So we are familiar with how to solve this. So we can use Cramer's rule. We can use any other method we know. So I will leave that as exercise. But by the time we finish, we should be able to get f is equal to minus 2, g is equal to 3, h is this, and k is 5. And take note that there is a mistake here. The other time we put minus 5 here, it should be minus, put minus 4, it should be minus 13. Discover this 9. Also, it will affect some of these things here. So this is minus 8. This is minus 27 minus 13. That will be minus 14. So by the time we solve it, we got all these things. What we now do is we substitute our values into all this. So your value for f, g, h, k. So by the time we finish it, we are going to have. So we have another example here. Find the equation of a sphere that passes through these 2 points, and the center lies on this straight line. Now, before we do that, we need to draw it for better understanding. Let's say this is the point we are talking about. This is a line. So the line is 4, 1, 2. Then this is another point here, which is 2, 0, 1. And this is the center of the circle. But we are told that this center here lies on this straight line. This one here. This is a straight line. But we know this is the center of the circle. Now, any line, any straight line, any point on this straight line in which this center of this sphere lies must satisfy this relationship. So in order to get this point, we need to express this line in its parametric nature, like this. This is the line. Let's equate it to, let's say, t. For this, so from that we know we have that s minus 3 over 1 is equal to t. So this will be s minus 3 is equal to t. The second one will have been y minus 2 is equal to 5t. This one will have been z plus 1 is equal to z plus 1 is equal to minus 2t. So from this place, we are going to have, if you make s, y, z itself formula, we have, now we have successfully expressed this line in its parametric form. So any point on that line must satisfy this straight line. So any point on this line can be expressed as this. Now, so in that case, this center is also a point on the line we are talking about. This place is also a point. So we can express this center here as this point. So in that case, I can say that, let me call this center O. So this place will be our O. And by definition of radius, we know that this place and this place are the radii of the sphere, which they must always be equal. What we are now trying to say in essence is that this point and this point, the distance between these 2 points must be equal to the distance between these 2 points. So let's write it like that. We can say that then OA must be equal to OB. All of them must be equal to the radius of the sphere we are talking about. Now, we have known our A. This is our O. Our A is 4 minus 1, 2. And our B is 2, 0, 1. So, by this relation, OA simply means the distance between O and A. You find the distance between these two. And if you still remember the formula for the distance, that is this minus this all squared, 3 plus t minus 4 all squared plus 2 minus 5t, 2 plus 5t minus this, it will now become plus 1 squared, and finally plus, this will be minus 1 minus 2t, and this minus 2 all squared. It must be equal to the distance between O and B. So it's still the same thing. This is 3 plus t minus 2 squared. This is 2. 2 is the first one. The second one is 2 plus 5 minus 0 squared. And the third one is minus 1 minus 2t minus this squared. So from that place, you observe that the square will cancel each other. We now need to rewrite this out. By the time we write it out, we are going to have, this. Now, what we have done is we have simplified all this and we have written them out. Now, the next thing is we proceed by simplifying the first one. So you can notice that the square root will cancel each other. So by the time we simplify this side and we simplify this side, we will get this. So from that place, it's now easy to find the value of our t. So we now need to see that the t is minus 1. So since you have found the value of t, so the center will not be too hard. So the center, which is O, will be this. This is our center. Remember, this is center. We substitute t to be minus 1. So by the time we put t to be minus 1, we are going to have the following, which is this. So we have found the center. We need the radius of the circle again, the sphere again. How do you now find the radius? So we know that OB is the radius. So that is the distance between these 2 points. So we only need to find distance between these 2 points or any of these two, since they must be equal. So we have known our O, we have known our B. Our O is this and our B is this. So the radius will be distance between them. That is 2 minus 2 squared plus minus 3 minus 0 squared plus 1 minus 1 squared. So take note that we can make use of A2 instead of B. So you can use any one you like. So by the time we finish, we get our radius is 3. Then we can now find the equation of the sphere, which is given as this. So this is our A, B, C. So you know O is the center. So this will be S minus 2 squared. Now this is Y plus 3 squared. And this is Z minus our C is 1 squared is equal to our radius is 3. Then we have 3 squared. So finally, we simplify it and get the final answer. So this is it. You have finally simplified. So this is the required equation of the sphere. Now let's take another example. So we have another one here. Find the equation of a sphere which passes through these 3 points and having its center on this plane. So solution. So we know that equation of sphere is given as this. Now we are told that the sphere passes through all these 3 points. So we take it one by one. We put S, Y, Z for this one, this, and just like what we did the other time. And if you do so, we have the following. So now we have substituted those values. So anywhere we see X, we put all these X, Y, Z, we put all these values separately that yields these 3 equations. Now, since we have done this, the next thing now is we need to find the way of eliminating it. Our aim is to find the value of ABC. So the first thing we do is let's subtract. Let's remove some things. This minus this, that is, let's find equation 2 minus equation 1. So that all this ABC will go. It will remain 2A minus is A. This minus this minus this minus this. We do the same thing for 3 minus 2 or 2 minus 3, anyhow you will like it. So it will eliminate all this A square, B square, C square. So when we do so, we are going to have the following. So we have this and we have named the 2, 4, and 5. But here now we have 3 variables with 2 equations. So we need to formulate one more equation. So let's go back to the equation. The equation now says that and having its center on this plane. And we remember that we know that the center of the circle has been assumed to be A, B, C according to equation of a circle. Now, we know that if any plane contains a point, then the normal vector of this plane will be perpendicular to the direction ratios of the point. So in this case, the direction ratio of the center is just A, B, C. So it will be perpendicular to the normal vector of this. So in that case, you can just turn it to 2A plus 3B plus 4C is equal to C. Since you have been told that this one contains the center, this plane contains the center of the sphere. So in that case, we can just write it as 2A plus 3B plus 4C is equal to 6. So that will be our equation 6. So it has now led to 3 unknown equations, 3 equations with 3 unknown. So by the time we solve it, it yields the following. A equal to 0, B equal to -2, YC is equal to 3. So since we have known that, we can now substitute in any of these equation 1, 2, 3 to get the value of our R. If it is equation 1, we substitute it there. A is 0. So we are going to, from equation 1, we have this. So I can now substitute A to be 0, B to be -2, C to be 3. That should not be hard to get. If you put it there, the value of R will come up, or the value of R squared. So by the time we put it there, we should have that our R is equal to r squared is equal to 14. It is r squared that we need. So let us now bring back whatever we get into the assumed sphere. S minus a squared, we put everything there. Hence, the sphere becomes this. We have put a there. This is our b to be minus 2, our c to be 3, and our r squared to be 14. So we just need to simplify it further and get the final answer. So we get this, and that is the required equation of sphere. So we'll meet in our next video to consider more on equation of sphere. Take care for now.